Hi, welcome to Advanced Python episode 5. Today I will go over and demonstrate the basics of regex, or also called regular expressions in Python, give you some simple examples, explain what it's all about and how to use it. After going over the basics, I will also demonstrate in step-by-step guide how to create a password checker, which will basically make sure that your password is secure enough. So basically the same thing which you can see all over the internet while trying to register to certain websites. Some of them will tell you that your password is not secure enough. You need to include a capital letter, a special character, symbols, numbers. That's basically what I will do after I go over the basics. What actually are regular expressions? Regular expressions, or regex, can be used to search for patterns or particular formats and parts in the text or simple strings. They can search for those patterns, they can identify where they start and where they end, and which part of the string actually follows our pattern. And if nothing inside of our string actually follows the pattern we're going to give it, it will simply return none. In order to use regex in Python, first we have to import an inbuilt library in Python called re, or re, for regex, and using this library we get access to a ton of commands. However, I will go over only a couple of them to show you the most basic regex syntax, as this library is actually quite complex and it would take quite a while to go over every single thing. However, down in the description you should be able to find the link where you can try and find out more about it yourself. The two most basic functions which you can use from this module are actually re.search as well as re.match, and they basically do the same thing. However, there is one difference. re.match only looks at the beginning of the string, and if that's wrong then it just doesn't go any further, while re.search goes over the entirety of a string and looks for your pattern everywhere. We are going to focus on the search one. There are actually two methods to use it. The first one being re.search and then in brackets inputting our pattern, comma, and then our string, and then there is a second method of just compiling the pattern beforehand and then using it slightly differently. The second way I just mentioned would have to be done in the following way. You have to give the name to your regex. Let's say I will just call it pattern, and then we have to assign to it re.compile brackets, open and close quotes, and inside of those quotes is where we would put our pattern. Then after we already compile it, instead of using re.search, you would use pattern.search. And then inside of the brackets, the only thing you would have to enter would be string, because we are already operating on the pattern, which means you don't have to pass it as the first argument. For now, we will focus on using the second version. However, when we go over to the second part of the video, I will switch over and use the first method. Okay, so now how do you actually create a pattern which you would check your string against? We can start doing that by first defining our pattern. For simplicity purposes, let's call it pattern again, equals re.compile, open and close quotes, and over here we actually have to follow a certain syntax, and there are many different symbols and characters which can be used to apply certain rules to our pattern. So let's go over some of them. So the simplest thing we can do at the start is tell our pattern to only look for capital letters from A to Z. To specify that, we have to open and close square brackets, inside of which we will enter our first pattern. To specify that we can only use capital letters from A to Z, you simply have to enter A-Z. The dash in the middle acts as a special character which signifies that from A to Z is an actual range of characters which it's going to search for. So this pattern now is looking for a single capital letter inside of a string. So we can go ahead and give it a test to see if it actually works. We can try to print and now use the command I specified previously, pattern.search, and inside of those quotes we can put our test string which we want to check against our pattern. So let's say that it will be a single letter B. If I run the file, you will notice that it prints something in the console. The middle part of that message shows you the span across that string which the matched part actually sits at. So as you can see here, the span is from index 0 to 1, exactly as here the span is from index 0 to 1. And the third part actually shows you the match, so the actual part of that string which was found to be correct when checked against your pattern. So in our case it was capital B. Now if I would change that string and make it use a lowercase letter, if we run it again, you can see that it prints out none, because our search function haven't found anything that matches our pattern. Because in our pattern we haven't specified any additional rules, but we're only looking for a capital letter anywhere in the string, we could enter any string we want, including absolutely everything, As long as we enter at least one capital letter somewhere in that string, we can start the file, and as you can see, it finds our A in the middle of this chaos, and it also shows you the exact index at which you can find it. So how do we prevent that now? How do we add some additional rules so that we can manipulate it further? There are many ways that we can do this. Let's for now simply say apple as our test string, and now let's modify our pattern so that the string it's looking for actually has to be fully capitalized. All of the letters have to be capitalized, there cannot be any small letters, and also let's make sure that our string doesn't have any numbers, doesn't have any special characters or spaces, it's capital letters only. To do so, we actually have to add two special characters to our pattern. The first symbol we have to use is the caret. The caret character actually specifies a condition that our pattern has to start at the beginning of the string and not any further, meaning that if we want only capital letters as our pattern and we specify a caret before that, it means that the only place it can find that capital letter is in the beginning of the string. So in our word apple, it should work. If I run it, you can see that it finds our capital A at index 0. However, if I change the A to be lowercase and then let's say I put E to be uppercase and I run the file again, you can see that returns none because the condition was not met. Our letter is capital, just like in our pattern. However, the caret condition specifies that it has to be the beginning of the string and that E is not at the beginning, it's at the end of the string. So is there a character that tells the pattern to look at the end of the string instead of the start of it? And yes, there is one. And it's actually the dollar symbol, which has to be specified at the end of our pattern. This dollar symbol now specifies that our pattern has to be found at the end of the string rather than the front of it. So if we run it again, you can see our E was found, and if we switch it over back to A being the capital letter, you can see it's going to print out none again. So now let's combine those both symbols. Let's put the caret at the beginning and the dollar sign at the end, stating that our condition has to start at the beginning of a string, it has to be present at the end of the string, and it has to be a capital letter. However, because we don't actually specify the range which we are looking for, this regex over here is only going to look for a singular capital letter. If I make the entire word capital, as you can see, all of the letters are capital. There is a capital letter at the beginning, there is a capital letter at the end. However, none of those letters are actually both at the end and at the beginning simultaneously, which makes them invalid. As you can see, if we run it, it's going to print none because it does not follow our condition. If we would like that to follow our condition, it would have to be a singular letter, because if it's a single letter, it is both at the beginning of the string, at the end of it, and it's also a capital letter. So if I would run it now, you can see that we have a match for A at index 0. So how do we tell our regex that we don't just want to look for a single letter? There are a couple of methods and I will show you some of them now. Let's go back to capitalized apple, and before the dollar sign, for that purpose, we could use the asterisk as our first symbol, which will tell our regex to look for as many patterns as possible starting from 0. So in that condition, if we use the capital word apple and we try our program, it will print the entire word apple because all of those are capital letters, and the asterisk tells it to pick up all of the capital letters in a row, and then all of those capital letters which were in a row and were found together are being put against the other requirements, so they have to be both at the beginning and at the end of the string, meaning our capital apple word is going to be found and the span is from index 0 to 5. However, if I would change a single letter to not be capital and run it again, it will give out none because now our A to Z with asterisk finds A, P, P, L, which are all capital letters. However, it does not touch the end of the string, meaning it's invalid. We can change our pattern again to work with that simply by removing the dollar sign, so that now the pattern we're looking for doesn't have to be at the end of the string. So if I run it, you can see we find APPL, excluding the E at the end, because those 4 capital letters I found by A to Z with an asterisk, and they meet the condition of being at the beginning of a string. So if we remove the caret again, and we just leave A to Z with an asterisk, we can add something at the beginning of the string, and it's going to be found. However, you may have noticed what I have said when I was trying to explain what the asterisk does, and I said that it looks from 0 to infinite matches. So what does that exactly mean in this current scenario? Well, it actually means that if I run it, we are going to get an empty string because our condition is being checked at the beginning of the string, and then the asterisk tells it that, oh, you had to have at least 0 matches, so that's fine, that's valid. And we don't want that to happen. We want to find at least 1 match and not just leave it at 0. So instead of using the asterisk, we can use the plus symbol. The plus symbol works exactly exactly the same way. However, instead of starting from 0 found matches, it looks for at least a single match and then everything above that. So in our current string, it will find APPAL anyway, and it will print it out for us. We can see that by running it again. And as you can see, from index 5 to 9, we found APPAL just like we expected to. Instead of just capital letters, you can also look for lowercase letters, simply replacing capital A and Z with lowercase a and z. And if I run it, you can see it finds the first part which matches, which would be ASDJH at the beginning over here. However, it does not detect E at the end because it's not continuous. It has been interrupted by something which doesn't match the pattern. You can also tell your pattern to look for numbers. So you would have to say from 0 to 9, and now it would simply look for numbers. So if we specify some letters and then a number and run it, you can see it finds 1598 and it gives us its index as well. And as I just mentioned, if we would interrupt that number, let's say in the middle, putting a letter instead and try to run it, it would only find 15 because the pattern which we're looking for has to be continuous. One thing which also has to be taken account for is using spaces, because if I would use space instead of A here, it would also print out only 15 because space is a kind of a special character and it has to be specified by itself. And we can make our pattern take a note of that space by utilizing escape character \s, which basically tells our pattern to look for spaces as well. So if we run it, you can see that the thing it found is actually 15 space 98 because we allowed our pattern to look for spaces as well. Another thing you can do, you can actually stack rules on top of each other by simply typing them next to each other. So in this case, we can specify our pattern can look for numbers, spaces, capital letters, as well as lowercase letters. You can leave it all next to each other. It's okay this way. You don't have to use any commas and spaces to separate it. The RE module actually takes it as a string and does operations on it by itself, so you don't have to complicate it more than that. And now we have specified that our pattern allows for numbers, spaces, capital and lowercase letters. We can run it. You can see the entirety of our string has been found as a match because it doesn't include any characters which would break that continuity from our pattern. If I would enter a special character, for example a dot after S and B for J, if we run it again, you can see that at the S over here is where it cuts off because that's where our string doesn't follow the pattern anymore. So now that we have went over some basics, let's go over and try and create a pattern for a more complex string, and let's define some rules for it. We will write what rules we want as comments so that we won't get lost and so that we can know what we're working for. So let's say that our string has to start with an uppercase letter, has to then include from 1 to 3 numbers, then it can include any amount of lowercase characters from 0 to let's say 100, and at the end let's ask for 2 to 3 special characters. Now that we have our nodes, we can start working on our pattern. So let's define a variable pattern equals free.compile, open quotes, and we can start adding our rules. The first thing we have to do is add the caret as well as the $sign because we want our string to be matched exactly from beginning to the end and not in the middle of a sentence or something else. We just want it on its own. In between those, let's specify our first rule in square brackets. We require a single capital letter, which maybe you can remember is A-Z, and without any additional rules, it's going to find a single capital letter. Next, we want to specify our second rule. Our second rule requires 1 to 3 numbers. So let's allow to enter digits from 0 to 9. And then we actually want to specify the amount of those numbers which can be entered. And we can do so by entering curly brackets instead. Keep in mind that if you're using curly brackets, you cannot actually use the plus symbol or the asterisk, which would allow to either enter from 0 to infinite numbers or from 1 to infinite numbers. We're going to specify an exact range. If I would be to enter a single number here, for example, let's say 5, it would first look for a single capital letter, and then it would look exactly for 5 digits. It cannot be less, it cannot be more. However, we can specify a range instead of giving a single number. So let's go as planned 1, 3, meaning that after our first capital letter is found, it's going to look for from 1 to 3 numbers. Let's add our third rule, square brackets again, lowercase letters, which can be specified by typing A-Z using lowercase letters. And then let's say that rather than from 0 to 100, let's just allow an undefined amount of them, which as previously mentioned can be specified using an asterisk. So what we've got so far is looking for a singular capital letter, then looking for a range from 1 to 3 digits, and then finally from 0 to an undefined amount of lowercase letters. After that, we only have one rule left, and that would be the 2 to 3 special characters. The simplest way to define special characters characters is to actually add all of our current methods, so capital letters, lowercase letters, as well as digits, and then reverse it so that our rule applies to everything but those three specified. So let's start by adding our filters again, A to Z, 0 to 9, and now to reverse that, in front of it, but still inside of the square bracket, we have to insert another caret, which simply means look for everything but those. And we obviously don't want just a single one, because if you don't specify anything after the square bracket, it will look for a singular one. We want to specify a range of 2 to 3. And now that we have created our final pattern, it should follow all of the rules which we specified here in the comments. We can quickly test it by providing a while loop, inside of which let's try and print pattern.search string input, and let's give it a prompt, try a code. We can run it, and as you can see, we're being prompted through our console to try a code. So now let's try to do something random, like leaving the string empty. You can say it prints out none because it doesn't match our pattern. If we try to enter, let's say apple 3 to 1, it's going to print out none as well. However, if we follow our pattern by providing first an uppercase letter, then 2 to 3 digits, let's say we will pass 2, then any amount of lowercase letters, let's say we're going to add A, B, C, D, after which 2 to 3 special characters, let's say that it will be an exclamation mark, a dot, and a question mark. And if we enter it now, you can see that our entire string has been found as a match because it follows all of the rules which we have specified. We can try and enter the same thing, but this time without using the lowercase letters to check if they are actually optional. And as you can see, it finds our string as a match as well. So let's start the second part of the video now, where I'm actually going to show you how to create a program that will check your password to see if it's strong enough, if it has capital letters, if it has special characters, all of those things, for which I will use regex. The first thing we have to do, just like before, is import re, and then let's create two variables which we will use shortly after. The first one being past, which we will set to a boolean of false by default, and then password, which for now will be an empty string. Make sure we can keep entering our password until it's fully secure without having to start the program a million times. We will use a while loop of while not past, which will keep on going until we change the value of past to be true. The first thing I want to do is ask the user for a password. So let's say password equals string input, and then let's give it a prompt of enter a password. Now I will make a list of all the checks or all the patterns which I want to check the password against. Let's call it checks, and it's going to be a simple list of patterns just like before. However, now instead of specifying everything in a single quote, we're going to separate it into multiple quotes, because the way we did it previously only allowed for that specific order of things, meaning that the capital letters always had to be first, then the numbers, then the small letters, then the symbols. It could not be any other way around. So now we will do this in a way where no matter in which order you enter the things, it's going to work anyway. So the first thing I want to make sure is that our password is actually at least 10 characters long, and we can do that by using first the caret character to make sure that we're checking from the beginning of the string, dot, which is actually a special character which specifies any characters, letters, symbols, numbers. It specifies pretty much everything with a few exceptions, and we want to give it a range of from 10 to unspecified, because this way it's going to make sure that it has at least 10 characters and pretty much any other amount above. But if you want to put a limit on the password length, you would put a number here. So for example 20, it would make sure that the password is at least 10 characters long but not longer than 20. I'm going to leave it empty. Now let's separate it by comma. So the second check I want to do is actually to check if our password contains a capital letter, and we can do that by first adding square brackets and then adding A-Z in capital letters without any symbol after it to make sure it looks for a single capital letter. The third check would be to make sure our password contains a lowercase letter. So the same thing again, but this time lowercase, square brackets, A-Z in lowercase. Another check to make sure that the password contains at least a single digit, 0 to 9. And then the last check will make sure that our password contains a special character. Just like before, we have to enter all of the previous modifiers and also add a caret at the beginning to reverse it. Caret A-Z, 0-9. And those should be all of the checks we need to make our password secure. Now, how do we actually use those checks to do anything? One method of doing that is using a for loop to check for current check in checks if re.search which is the second method of using the regex like I shown in the beginning. Instead of using the compile method, we're going to simply do re.search, then enter our current check, which is going to be the pattern, comma, password. So now our for loop is going to go over every single check in our list, and it will use an if statement to make sure that our password actually matches. But to be able to do so, we actually have to specify one more thing, and that if re.search is none. So in case our search turns up with nothing because our password is not secure enough, we will do two simple things. The first one is printing a message notifying the user that his password is not strong enough, and the second one is a simple break statement to break out of the for loop, because we don't have to continue with checks if one of them already failed. So now that we have our print statement and our break statement, we can go over to the second part of our if statement, else if, meaning it will only get checked if the check was actually valid and was not equal to none. We will make sure that current check equals checks of index -1, meaning that it's the last check from our checklist, and we're making sure that the current check is indeed the last check, and because it already passed this first if statement, we already made sure that all of the checks were valid at this point. So inside of that statement, we can change passed to be true. At this point, our password would have already passed all of the checks, passed will be set to true, the for loop would end because it was the last check anyway, and because passed is no longer false, our while loop would finish as well, so we can print a final statement notifying that the password was secure enough. And that should be the whole thing. We can start it now and make sure it works. Run it, and let's try to enter some passwords. The first one, let's just try to leave it empty. As you can see, that password was too weak, so we can try again. Let's say kiwi, which is also too weak. Let's try and enter something complicated and long, like randomly mashing your keyboard. And as you can see, our password was secure enough, because it's at least 10 characters long, it has both uppercase and lowercase characters, a digit, as well as a special character. And that would be it for today. See ya!